All good for you to start.
Okay, great. Thank you. So I wanted to start off here and thank everyone for letting me here and talk about generative AI and 3D printing. And I wanted to introduce myself. My name is Taj Sarin. I have been in the 3D printing space for roughly 8 years now. And I've more recently got into the AI space as well. My background stems from the US Army as an engineer, and I studied aerospace engineering. I'm a big nerd, self-proclaimed nerd. And I love all things tech. So without further ado, I think I'll kick off this presentation and how AI and 3D printing is really shaping the future of not just design and manufacturing, but many, many other things. Okay. So I want to give a brief overview of AI and 3D printing, and as well as an importance of AI and how the importance of AI in advancing 3D printing technologies itself. 3D printing has been around for quite some time, but it's been more relatively recently been made more available to commercial industries and private individuals as well. And it's really kind of accelerated that market and the technology as well in that space. If I'm going to assume that there is at least a broad level of understanding of 3D printing and AI in this presentation. So I don't want to get too nitty-gritty here with the 3D printing because we can go on and talk for days about that specifically. But 3D printing itself in terms of additive manufacturing and how it works with a printer literally creating something with molten polymers essentially layer by layer. And it uses a slicing software. So if you take something that's three-dimensional and slice it in two-dimensional X, Y, Z coordinates, you essentially get a file that's called a STL file that you can print. And there's software that's involved in doing that. And kind of the cool thing here recently that we're seeing is how AI is being adapted in this field as well. For example, I'll actually provide a lot of examples later on, but it's really important how AI is actually revolutionizing the space and accelerating innovation and rapid prototyping. I want to kind of give a brief overview of how 3D printing is really being adopted across key industries here. And as you can see here, it's relatively slow, and it's pretty interesting to compare this to AI as well, in the sense that I like to compare AI to the whole dot-com boom, in the sense of when the dot-com boom happened and the internet kind of like exploded, everyone was kind of like, oh, wait, I don't want a website. We don't need a website. We don't need to do this. Or there was a large fear about it. And we're kind of seeing that with AI as well too. And there's slow adoption. And 3D printing is kind of similar in that nature, but it's being adopted more heavily. Obviously, you can see in the industrial sector, healthcare, and automotive especially as well. Moving on, we can talk. I want to talk about how AI is actually optimizing design and generative design as well. So one aspect of 3D printing is when you're in a CAD program or computer assisted drawing program, you're putting together, a three-dimensional object that is to be sliced and produced physically with a 3D printer. So one aspect of how AI is assisting with this is quite literally you're having CAD algorithms that are in place and optimizing these design schemas for 3D printing or for very specific materials, for example, which is pretty cool to say the least. I think, I remember, and this is still around, so Tinkercad is a free CAD software that's online. I want to give an example, a very simple, basic example of how AI, generative AI, or specifically GPT, is assisting in design processes. And this is a very, very simple example of, hey, ChatGPT, give me an image of a simple design of something I can design in Tinkercad to 3D print. So this kind of like, and the point of this is really, it's not providing me a three-dimensional file or an STL file yet. There are some softwares that are going to be starting to introduce things like that relatively soon. But what I think this really proves is the design process itself, the innovative thought process of actually bringing an idea from your head to a piece of paper to quite literally a physical object is shortening significantly, because you can leverage GPT models to give you a kickstart, to kickstart that idea. Okay, so this is great. This is a functional, it looks like a desktop device that can hold, pencils, pens, and I was really, the DALL-E 3 was very good at, creating this interesting design here. And I'm going to move on to a more complex use case. This is, oh, you can't really see the bottom here, so I'll read that out for you. But this is a hyperganic EOS rocket nozzle, which is designed by a CAD algorithm using a Titan Core processor. This is pretty relatively new. I believe this was designed last year using a nickel alloy. So this was actually designed and then actually 3D printed. Now, it has not been tested yet, but apparently this specific rocket engine, or rocket nozzle, I should say, not engine, it was designed beyond the capabilities of human imagination. And what I mean by that is that it had, the AI itself had in mind, or the specific algorithm had in mind, um, flow vectors and specific aerospace calculations that would be very, very hard for a human imagination to just come up with, right? So this is pretty interesting, and I'm curious to see how these types of technology, or these types of 3D printed aerospace parts actually come into the market, and how it's going to really change and revolutionize travel, or space travel even. Moving on, another aspect of how AI is kind of creeping their way into 3D printing space is predictive maintenance. One really cool feature on some of the more advanced 3D printers is that they're able to predict when specific parts in that 3D printer need to be replaced. And it could be a simple algorithm that involves, okay, you've printed X amount of times, or you've printed using this specific material over this length of time. Or it can be as complex as, okay, we have variables being measured across every aspect, or sensors across every aspect of that 3D printer, and we know when a specific part is going to break over time. And we have AI algorithms that are able to predict when a printer needs to be maintained or replaced. Quality control. Another aspect here is we're able to, for example, another aspect of how AI could be incorporated into 3D printing, and how it will be, is quality control in the software slicing itself. So one example of that is, if I want to print out an automotive part in a specific alloy, specific metal, but it turns out that the quality is, there could be a specific algorithm in the software itself that could tell you if the quality is not on par, or within reasonable safety standards. Even there are specific parameters you can measure it against, so that could be a huge aspect as well. And another aspect that is currently being implemented is LiDAR detection as well. So some of the more latest available 3D printers, known as Bamboo Labs, that company is actually, and Creality as well, as incorporating LiDAR detection. So it literally has a LiDAR sensor on the nozzle and is able to detect any print failures. Now, right now, it's pretty rough in the sense of it's not able to really fully detect a failure from a success. But over time, as any AI algorithm or machine learning algorithm, over time, as it collects more data, it becomes more refined, and you're able to actually predict much more efficiently if a print is failing or not. And this could significantly reduce costs. It could significantly reduce failure rates, and that could be a really big area in how AI is merging with 3D printing. Supply chain integration. So this is another cool thing to think about, of how AI is going to really optimize 3D printing in the supply chain aspect. So I think, imagine for a second, if you're Amazon and you are this huge logistics company, and you're trying to get a package A to consumer B, and let's just say, for example, that product A is 3D printed. It's entirely 3D printed. Now, if I am able to have predictive analysis, or an AI on the back end that's able to determine supply and demand ratios across an entire year or seasons, I could have automated 3D printing systems in a warehouse that will just pump out the product that I want at the time that I need in the most efficient manner ever. You could even have it optimized to print out at low peak, electricity times, for example, where you're not paying as much for electricity, and it can measure all these variables, and it could significantly reduce costs for not just manufacturers but for consumers as well. Another aspect of AI 3D printing is defense. So one big, and just as a little joke on the, coming from a U.S. Army background, the military is very good about acronyms. So I kind of took the pleasure of creating some of my own acronyms here. And some of the concepts here that have been talked about. DARPA has done a lot of research in this area as well for rapidly deploying factories, essentially mini factories that could go out into a forward operating theater and deploy and be able to create a FOB or a forward operating base right then and there. This thing could be dropped out of a AC-130 aircraft in a shipping container and just deploy and be able to produce its own materials and supplies. Now think about how powerful that would be in a theater, for example, in Ukraine. Like there's a huge supply chain issue there with getting the right amounts of weapons and ammunition to specific members in that theater. So having something like this to be able to rapidly deploy it when it's needed, where it's needed, would be very significant. The 3D printing in that aspect would be huge. Moving on to space, this is one of my favorite topics as well. So space, I think in 3D printing is really, and especially in AI, how they're both going to merge together and be able to revolutionize the space industry is going to be significant. 3D printing has already been huge in space. I remember, I think it was 10 years ago that I remember hearing about the first 3D printer they actually had on the International Space Station. And it was a huge MIT project, I believe. And correct me if I'm wrong there in the comments, but this is significant in the sense of how a 3D printer could actually operate in a zero gravity environment or a low gravity environment. And one of the three aspects here of that where AI and 3D printing kind of merge in the space industry is through. So in situ resource utilization. So I think kind of similar to the defense aspect of dropping a 3D printer in the middle of on the moon. And being able to create 3D printable filament or materials from the regolith that's on the lunar surface. Why would you need to bring all the materials yourself? You could just put a printer there, some robots, collect a little lunar dust, make your own filament there, and start producing your own habitats there. Now, that's one simple example, not so simple, but one example. And we can even think about Mars and other planets as well, and asteroids even. So it's kind of huge in the sense of, and where AI would fit in this is the AI would be able to determine the best area on a lunar surface based on probe data. And I think it's important to also say that AI really just revolves around data itself and the importance of data. So the cleaner data you have, and over time, as you get more data, the smarter the AI becomes. So you're able to actually create systems where, for example, you're able to determine, okay, this area on the lunar surface is the most optimized or most optimal for producing, a high strength filament that would be ideal for a habitat to be produced. I think those types of concepts are definitely on the drawing boards right now, and there's definitely talk about doing stuff like that. Spacecraft repair is another big one, especially during long trips, for example, to Mars, for example, or even the moon. The moon is still a 4-day trip. If something breaks on your spacecraft, how are you gonna repair it? It's you don't want to just send up a rocket, to meet up with your spacecraft to give you the parts. They're already doing this on the ISS, the International Space Station, where if there's a part, NASA would actually literally just send the file to the ISS to be printed out. And this could go even further when you incorporate AI, and the AI is able to predict, for example, predictive maintenance. When you need to replace a specific part, that 3D printer on the spacecraft could just automatically start printing it out when it's the time to actually replace that part. That could be significant. And I think I went over as well automated habitat creations as well. So just sending out something before you even send any human travelers to a specific planet. You could send out a 3D printer and it's able to create its own filament. Another a cool aspect of the in situ resource utilization is Amazon actually just recent, or Blue Origin, I should say, recently just created solar panels using just regolith. And regolith, just for anyone who doesn't know, regolith is literally the lunar material that's on the surface of the moon. So they were able to literally create solar panels out of rocks on the moon, just rocks on the moon. So that's a huge thing, because power is, electricity is very important in any aspect of AI and 3D printing. You need power to power these things. All right, so future outlook here, and here like are my thoughts. These are my own thoughts and my own opinions of where AI and 3D printing are really going to go. And it's my own opinion that I think 3D printers are going to be in every single home and commercial buildings very soon. You're already seeing it today. I'm seeing a lot of commercial facilities and maintenance facilities that have 3D printers on hand. A lot of universities, a lot of schools have them now. And I'm starting to see a lot of people just pick them up for their kids as well. And that generation starting to learn how to operate 3D printers at a very young age. And I think in the next 10, 20 years, it's going to be pretty prevalent and probably standard for a lot of places. Number two, I think, is true plug and play. And what I mean by that is the most recent updated printers that have been released. I'm going to use Bamboo Labs as an example. Is a P1P or X1C carbon. Their printers are absolutely phenomenal, in my opinion. I know there's a lot of debate across many different manufacturers in the 3D printing space. But true plug and play is really quite literally, I buy a printer, plug it in, I send something from my phone, and it starts printing. And we're very close to that. I think that's going to happen very soon. I think that's going to happen in the next 10 years, and end-to-end automation will probably be the next best step. And if you think about the Internet of Things, imagine owning a home, a smart home. And I think this goes back to the predictive maintenance. I have all these things that are connected to the internet. I now have an AI monitoring if a specific part in my plumbing needs to be replaced. My in-home printer now gets sent something over the local Wi-Fi network. Hey, we need to print out this new part to be replaced, right, in this plumbing system. It prints it out automatically, sends you a notification. Boom. Now you gotta. Hopefully, you won't have to by then. You might have, Optimus, the Tesla robot, that will do it for you. Who knows? Number four would be micronization and nano printers. So this is a big thing, because micronization is a very powerful thing that's occurring in a lot of different industries. And sorry, it's my dog's in the background, but micronization is really about reducing the size of sensors and really being able to produce these sensors efficiently and effectively. And that's been a very, very big thing that's trying to, a lot of people are trying to do this, and it derived from the space industry during space exploration, because the cost to take something to space was very expensive. And there was these research studies done on nanosatellites and cube satellites, and what do we do to cram as many sensors as we can into one small specific device. So my point here is that the micronization and nano is going to come to 3D printing as well, and AI is going to assist with that. And when you have smaller and smaller devices, smaller printers that can produce bigger things, I think that's going to be huge. And I think this is way down the road, but number five would be fully autonomous molecular nanobot printers. So when you have actual 3D printers that operate and on a network, essentially, on a molecular scale, I mean, we're talking Star Trek level replicator stuff, but that's all stuff that could actually happen with AI and having that aspect drive this technology forward. It's definitely in the realm of possibility. I mean, there's a lot of people that thought the things that we heard about in Star Trek and Star Wars, we never thought we'd see, but here we are. And there's a lot of different things that we're seeing now that we've saw in sci-fi. So I want to thank everyone for listening to my presentation here. I put some resources here. I own a 3D printing company and an AI consulting company as well. Feel free to check me out. And with that, I'll leave everyone with a quote. We all have our time machines, don't we? Those that take us back our memories and those that carry us forward our dreams. That's by H.G. Wells. Thank you very much.